And then the last one is, provided that they're a basketball player, what's the probability that they're over 6'1"? I think that's a big proportion of people. Given that they're a professional basketball player, they're over 6'1". Yes, that's going to be probably a pretty big portion. So that's the answer right there. This next problem deals with that Forrest Gump box of chocolates. Now they said that all the chocolates look identical, and 14 have soft centers, and 6 have hard centers, okay, out of 20 chocolates. So this is our first pick, right? We either pick a hard center or a soft center. And then we pick our second candy, which is going to look like this. Now, if we picked a soft center, there's not going to be another soft center, so there's one less. So it's going to be 13 out of 20 that you get a soft center one. And then there's still 6 out of 20 for the hard center, like that. Okay. And then, again, if we have already picked the hard center, it means that there are still 14 out of 20 soft center in the box, but we already picked a hard center one, so there's only 5 left, 5 out of 20 for the hard center. So that's soft and hard center. Okay, that's what the tree diagram looks like. I think these problems are going to be kind of messy because I'm in a bit of a rush. Dinner's on the way. So the B part of this problem says, what's the probability that you get one of each? I'm going to draw a line. So if I pick a soft center and then get a hard center, I just kind of multiply along that line. It's going to be 14 out of 20 multiplied by 6 out of 20. And then we look at the other way. What if we pick a hard center one first and then we get a soft center? So we just multiply along that line, and it's going to be 6 out of 20 times 14 out of 20. And so you multiply these two together, and then you add them together, and you get your answer, which looks like this. So your final answer looks like that. And if you put it in a decimal form, you're going to get 0.4421. So somewhat less than half of a chance of getting one of each. There you go. Well, this problem asks you to write a tree diagram. So you have 3 different grades of gas and whether the customer paid with credit card or no credit card. So let's do the 3 different gas, right? Looks something like this. And what was it? It was regular, mid-grade, and premium. And then, let's see, we're just going to do, on each one of them, you could either pay with credit or, let's just call it no credit. Credit, no credit, and credit, and no credit. So you have basically 6 different outcomes. The gas they bought and how they paid. Let me put the probabilities for each one of those on those branches. So based on what they tell you in the problem, here are all the probabilities for each one of those. So for instance, what's the probability that they bought mid-grade and paid with cash, not credit card? So we just follow this line. We would multiply this out. So 0.02 times 0.66 would give us that probability. So I'm going to multiply all the probabilities. For instance, regular and credit card, multiply those. Regular and cash, multiply those too. Okay? And I'm going to put those all at the ends of these branches. The probability of each one of those. So there you have all the probabilities of each different situation. But the question asks, what's the probability that somebody pays with credit card? So what we do is we take all the credit card purchases, mid-grade, regular, and premium, and then we add those together, and that will be our probability that they pay with a credit card. And yes, I know I did not use the four-step process, which is state, plan, do, conclude. State is state what you're trying to figure out. Plan is how are you going to do it, which is the tree diagram. Do is do, showing the tree diagram. And conclude is the fact that you have almost 1/3 of your customers using a credit card to pay for their gasoline. There you go. Let's move on to the next one. Whoops, we better go to 85 on this one because they refer to the same question. So it says something about what's the probability, provided that a customer pays with a credit card, what's the probability that they bought premium gas? So that's going to look like this. The probability of, like this, provided that they paid with a credit card, what's the probability that they bought premium gas? So if we look at the formula, that's going to be the fact that what's the probability that they bought premium gas and they used a credit card divided by the probability that they used a credit card. So it looks like that. The probability of that divided by the probability of that. Hold on a second. So we just figured out the probability that they pay with a credit card. That's this one up here. So that's, I better write that down, 0.2952. And then we say, well, what's the probability that they bought premium gas and used a credit card? Well, we follow this branch out right here. Okay, premium gas and used a credit card, 0.042. Let me write that down now. And we get this as an answer when we divide these two things. So the probability that provided they pay with the credit card that they got premium gas, 15%. There you go. Next. This problem has to do with a kidney transplant and whether you're going to survive for 5 years. Now there's quite a few numbers in there, and if you read it a couple times, let's just start out slowly, and we get the tree diagram. You're either going to survive or you're going to die. This operation, that's the first piece of it. So survive or die. You have a 90% chance of surviving and a 10% chance of dying. So there we go. Now the next part is whether the transplant succeeds or if you have to go back to dialysis. So we're not going to worry about this because you're not going to go back to dialysis if you died. Now, so we really only have to worry about this branch up here. This one and this one. So this is a transplant success, or let's put dialysis. And that was a 60-40 chance. So 60 here and 0.4 down there. And then if your transplant succeeds, you have a chance of surviving for 5 years, and that was a 70-30, 70% chance to survive and 30% chance to not survive. Okay, that's for 5 years. And then if you go back to dialysis, you've got basically a 50-50 shot of surviving for 5 years. And that was survive or die. And we're talking about for 5 years. Okay. So we are interested in survival, right? Survival for 5 years. So what we should do is just multiply along these branches, right along here. That gives us the probability that the operation is a success and the transplant takes and we survive for 5 years or more. The other option is, again, we survive the operation but we go back on dialysis and we also survive for 5 years. So we multiply along these lines. So here's this one. Multiply this times this times this, and I'll do that. And there you go, 0.378. Now let me multiply the other one, which is multiply this times this times this. That's our other pathway. Actually, it kind of looks like a artery, blue and red veins and arteries and stuff. Anyway, getting tired. And there you have the two probabilities for surviving for 5 years. Well, then we add them together, and it gives us the total of the two situations. There it is. You got a over 50% chance, 0.558, better than flipping a coin. So let's go for it. Okay, next. So this one is kind of like that cafeteria video I made. So these are all probabilities. I didn't put that down. So the probability that they have Facebook is 0.85 and MySpace is 0.54, and the fact that they have both is 0.42. So the question is, provided that the person uses Facebook, what's the probability that they also use MySpace? So that's going to look like this. Provided, let's see, that they have Facebook, what's the probability that they also have MySpace? So what's that going to look like? That's going to look like this. The probability that they have Facebook and MySpace divided by the probability that they have Facebook. Well, that looks pretty easy. They gave us most of the stuff there. So it's 0.42, the fact that they have both, divided by 0.85, which is the Facebook stuff. And the answer is going to be 0.4941. Pretty darn close to half. Okay, let's do the next one. This problem has to do with whether you're lactose intolerant and based on what race you are. I kind of wish they did one on chicken allergies, but anyway, I didn't do all the stuff. You put your probabilities for white, black, or Asian, and whether you're lactose intolerant versus not lactose intolerant on each one of those, and you multiply each one of those. So multiply the probability that you're white times the probability that you're lactose intolerant gives you this number. Multiply the probability that you're white versus the fact that you're not lactose intolerant gives you this number. Okay, I just didn't do that, but if you want to know the probability that you're lactose intolerant, you just add up all these L's and you get your answer. But then the next part asks you, provided that you are lactose intolerant, what's the probability that you are Asian? Let's take a look at what that looks like. So here it is. Provided that you are lactose intolerant, what's the probability that you are Asian? So that's going to look like this. The probability that you are Asian and lactose intolerant divided by the probability that you are lactose intolerant. Okay, so let's look at those two probabilities. The probability that you are Asian and lactose intolerant would be right here. Asian, lactose intolerant, right here. So let's write that down. That's going to be 0.36. I had to back that up. Let's see. It's 0.036. 0.036 divided by the fact that you're lactose intolerant. Well, that would be all these three guys added together. So let me do that. And there it is. 0.036 Asian and lactose intolerant divided by lactose intolerant, which is all three of those guys added together. And my final answer is going to be 0.14. So I have a 14% chance that you're Asian and you're lactose intolerant, provided that you're lactose intolerant, right? So provided that we're lactose intolerant, what's the probability that we are Asian? 14%. Okay, so that wraps up the homework assignment. I hope this is helpful. I know that I went pretty fast, but anyway, I will see you tomorrow. Bye.